Today we're going to be talking about how the phases of the moon are created. So we have the sun on the very left side of this setup and the moon and the earth, and we're going to focus on the moon and the earth. The sun is not going to move for this demonstration, and we're not even going to show the rotation and revolution of the earth, only of the moon. Now we can see that because the moon and the earth are being lit up by the sun, the half of it that is facing the sun will always be illuminated. So as I take the moon and move it around, the half that's facing the sun is always going to be lit up, no matter where it is in its revolution around the earth. The thing that causes the phases is that we can't always see the same amount of that lit up portion. So I'm going to move the moon back to where it is in between the sun and the earth. So when the sun, the moon, and the earth are lit up, are in a line, half of the moon is lit up, half of the earth is also lit up again. Half of the earth is always in daytime, half is always at nighttime. And if I come down and look at the moon as I would see it from the earth, so I'm going to line this up, take the earth away, and look at the moon from where the earth was, we can see that we can't see any of that lit up portion of the moon. Half of it is lit, it's just not facing the earth. So when the moon is in this position, we have the new moon phase, which is where we can't see any of the moon. All right, if I put the earth back and start revolving the moon around it, so now I've got the moon kind of in this position with the sun and the earth. If I come and take a look at the moon from the point of view of the earth, I'm going to move the earth out of the way again, we can see a little crescent of that lit up portion. So the right side of that moon, we've got a little sliver of lit up portion that we're able to see. This is called a crescent moon. As the moon keeps revolving, and now I've got it at a 90-degree angle with the sun and the earth, as we look at the moon from the earth, we can see exactly half of that lit up portion. So this is a half moon, or a first quarter, depending on who you ask. And yes, the first quarter does equal a half a moon, which is weird, but I'm sorry, that's the English language. As the moon keeps revolving, now in this type of arrangement, from the earth, we can see most of that moon, not all of it yet. So there's that little crescent piece on the left that is still in shadow. This is called a gibbous moon, and we've got that little crescent in shadow, and the majority of it we can see. If we keep revolving so that the moon is on exactly the opposite side of the earth from the sun, so sun, earth, and moon in a straight line, now looking from the earth, we can see the entire moon lit up. So we have the full moon phase here. If we keep revolving it, all right, now we can see another gibbous moon, but this time the sliver of shadow is on the right. The moon's starting to get smaller. And as it continues to revolve, it gets smaller so that I can see now only half, the opposite of the half that I could see before. Even farther, and I'm down to another crescent. Again, the crescent's on the opposite side of what it was before, and then it keeps getting smaller and smaller and smaller until, as it's lined up with the earth again, we can once again see none of the moon, and we are back to the new moon phase. So one complete cycle from new moon to new moon takes about a month, a little bit less than that, but approximately 1 month for one complete cycle of the moon. Again, half of the moon is always lit up, but depending on what portion of that we can see, we go from seeing none of it to seeing a little bit of a crescent to half to just a crescent of shadow that shrinks and shrinks and shrinks till we can see the entire portion that's facing us illuminated, and then it gets smaller and smaller and smaller again until it's completely gone. And again, that cycle takes about 1 month.